Nobody was talking to you.
Okay, but you are now.
Okay, well, I don't care.
You guys are being recorded. All right, number 1. The table at right shows some points from a quadratic function f of x. What is the value of x whenever f of x equals 6? So remember, f of x is another name for y, so it's saying when y equals 6. So when I look over here, I have a 6 here and a 6 here, and that is whenever x is 2 and x is 4. So the answer would be C. Okay, number 2. When graphed, which function would appear to be shifted 4 units down from the graph of f of x equals x squared plus 3? So anytime that it's shifting up and down, that's the vertical shift, and that has to do with our k value. So what I need to do is take the k value in the equation, which is 3. So if I am shifting down, that means I'm going to subtract 4 from 3, which would give me -1. So my new equation would be f of x equals x squared minus 1. So A is my answer. Number 3, what are the zeros of the graph below? So zeros is another name for x-intercept. So I see that I have 1 0 at -3, 0. And then I'm going to treat this y-axis as my axis of symmetry because it's what's cutting my parabola in half. So then I know that this this x-intercept is 3 units away from my axis of symmetry, so the other one will be the same since they're symmetrical. So therefore my other point would be 3, 0. All right, number 4. It says a toy rocket is launched from ground level with an upward velocity of 64 feet per second. Its distance from the ground can be determined from equation h equals 64t minus 16t squared, where h is the height in feet and t is the time in seconds. So the first question is asking us how long the rocket is in the air for. So we just look at our x-axis here and we can see that it's in the air for 4 seconds. Okay, the next question is wanting to know the maximum height of the rocket. So that has to do with our y values. And I see that it's about 65 feet. Because that's what is in between 60 and 70. Okay, and then C is saying the rocket was at a height of 30 feet at blank seconds and blank seconds after it was launched. So again, for my y-axis, I'm just going to draw a line so I can see which 2 points it's hitting that line at 30. So I come down and see this is about 0.5, and my other point is about 3.5. So 0.5 and 3.5. All right, number 5. How would the graph of the function y equals x squared be affected if the function were changed to y equals x plus 5 squared? Since this x plus 5 is inside the parentheses, that's very similar to having our x plus h, so it has to do with the horizontal shift. So remember, it's always going to be the opposite. We wouldn't be going towards the positive values. We're actually going to go towards the negative values. So that means we would be going to the left. So the graph would shift left, or I'm sorry, it's asking for how many? 5 units to the left. All right, let's go on to number 6. So what is the vertex of the graph of the quadratic function y equals x minus 3 squared plus 8? So this is in the vertex form. Remember, y equals a times x minus h squared plus k, where my vertex is h comma k. So recall that whenever I pull that value out of the inside of the parentheses, it's always going to be the opposite. So it won't be a -3, it'll be a positive 3. And then my k value is going to be 8. Okay, and the axis of symmetry is always going to be the x value of my vertex. So it's going to be x equals 3. And my domain will be all real numbers, because it's going to cover all the x values. All right, number 7. A book was dropped under a motion detector. The following data was collected. So it gives me these points here from the table, and then it says, which of the following best represents the relationship between the distance from the motion detector y and the elapsed time x? All right, so we are working with quadratics, not linear equations. So right away I can get rid of d and c because they don't have the square on the x. And then when I look up here, I see that I have a y-intercept of 0 and 4.5. And I notice that my y-intercept is a positive 4.5. So that automatically eliminates A because it has a minus 4.5. So that leaves me with B since it has the plus 4.5. But I also could use stat edit as well to figure out what the equation would be. All right, number 8. The table below shows some points from a quadratic equation h of x. What is the range of the function? So in order to find my range, I first need to know what my y value is for my vertex. So remember, I do the little rainbow to find my symmetrical pairs. And what lies in the middle of the rainbow is always our vertex. So that's 0, 5. Now I need to look to see if my numbers are increasing or decreasing. So 5 to 6 to 9 to 14 means they are increasing. So therefore my parabola is facing up. So it would be y is greater than or equal to 5. So the answer would be C. All numbers greater than or equal to 5. Okay, number 9. What is the range of the function shown on the graph? So again, since it's asking for the range, that means we're focusing on our y values. So the graph, it has a starting and stopping point for this one. So its highest value is going to be at 5, and its smallest value is going to be at -4. So that means -4 is going to be less than or equal to, and it's going to be equal to because my parabola is going through that point, and then y, and then it's only going to be less than 5, and it won't be equal to because remember I have an open circle here, and in order for it to be equal, it has to have the closed circle. So my answer is D. All right, on the back side. Number 10. Which graph can be obtained by translating the quadratic function y equals 0.28 x squared minus 4 up 7? So again, they're talking about a vertical shift, which has to do with our k value. So since it's saying up 7, that means I'm going to take the k value currently in the equation, this -4, and I'm going to add 7 to it. So that gives me a positive 3. So that means my answer would have to be this one right here, since my vertex is right here on the value 3 from the y-axis. Thank you. All right, number 11. A section of the graph of a quadratic function is shown. Which of the following points is also a part of the function? So again, we can use our y-axis in this one as our axis of symmetry, because that's what cuts our parabola in half. So to determine what my other points would be, I'm just going to find their symmetrical pairs. So just like how this one is 2 units away, the one on the other side will also be 2 units away. This is going to be 3. And then this one up here is 4. So there's the rest of my parabola. So let's see, this point is, this is 4, 7, and that looks like it's our option right there, B. Okay, Number 12. The scatter plot below shows the relationship between the side length of each square and its area. So which of the following is the closest to the side length of a square with an area of 55 square units? So over here is the area of square. So 55 would be about right here. So it looks like it would fall in between these two values if we followed the trend of the plots. So when I come down here, it's between 7 and 8. So our best guess would be B. Okay, 13. What is the y-intercept of the following graph? So my y-intercept is where my parabola is going to cross the y-axis. So that's down here at -6. So that means my y-intercept is 0, -6. And now it wants to know the range. Well, this also happens to be my vertex here. And I see that my parabola is facing up, so since it's facing up, that means I would have y is greater than or equal to, and I'm always going to use the y value of my vertex, which is -6. Alright, number 14. Which graph best represents a function with a range of all real numbers less than or equal to -6? So if it's y is less than or equal to -6, that means my parabola has to be facing down, and it has to have a vertex with a y value of -6. So it can't be that one. This one's facing up. It can't be that one, so that leaves us with C. And you can see it's hitting right there on the 0, -6. All right. Number 15. 15 is asking for the range of y equals -x squared plus 6x plus 9. So what I need to do is go to the calculator, into y equals, and I put in my equation, -x squared plus 6x plus 9. And then I'm going to go to the table because I want to find my vertex. So I see that my vertex is 318. And I know that because I have these repeating 17 on each side of the 18. And then I also can see that from 18, when I go down, my numbers are decreasing. So since they're decreasing, that means my parabola would be facing down. So therefore, I'd have y is less than or equal to, and again, I'm using the y value for my vertex, which would be 18. So that would be my range. Thank you, Julio. All right, so number 16, if the quadratic function y equals x squared is shifted so that the vertex is 6, 1, which equation best represents the new function? So we're going to, if you look here, you can see that these are all in the vertex form, which is the y equals a times x minus h squared plus k. And from my vertex, I know that it's h comma k, so that's how I know how to plug in my values. There's not an a value, so that, or my a value is 1, so we can just leave that out. And then we would have x minus 6 squared. So again, my 6 is my h value. And then my k value is 1, so it's going to be plus 1. So therefore, B is my answer. All right, number 17. How would the graph of the function y equals x squared be affected if the function were changed to y equals 1/2 x squared? So I know that the a value in the y equals x squared, my quadratic parent function, is 1. So when I compare it to my new a value for my new function, I know it's getting smaller. And this one is the one that is in between 0 and 1. So that means my graph would be a vertical compression. So therefore, the graph would be, it would get wider. Okay, last one, number 18. The graph of f of x equals x squared is transformed to create the graph of g of x equals 1 over 3 times f of x. So which graph best represents the function f and g? So if this is saying g of x equals 1/3 times f of x, and we know that f of x equals x squared, that means g of x is equal to 1 over 3 x squared. So again, the a value in the f of x is 1, and g of x has an a value of 1/3, so g would have to be wider than our f of x. So it can't be this one because g is lying inside of f. And then this one right here, you can see, is showing that it's wider, where f is narrower, so this would be our answer. We would also know it's not this one because there was no type of vertical shift. All right, and that's it.